we're going to make a bit of progress here on wiring the battery to get the power to the controller. I've made a little channel here, got some conduit, some plastic conduit. This is going to sit under the seat. I had to mold the bottom of the seat here. It's basically nylon. I just had to heat it up and mold it so I can actually get that to sit on there when I'm done. I'll try and show that when I'm done. And then essentially this comes in here like this. Sits about like that. That wraps around there, brings the wire down safely underneath the seat, and then I gotta bring it up to the controller. So DigiKey, I just remembered, screwed up and sent me the wrong package. Where did I put those? I have to remember where I put them, because I don't even know what I'm going to do with them after that. But as you can see here, DigiKey shipped me a package. I ordered 10 battery cable lugs, one slot, 1/0, 5/16 hole in them. And as you can see in there, these little 12 position con plugs, connection plugs are in there. They're little plastic guys. You can see a couple there. I have 550 of those, and I talked to DigiKey support today, and they said just keep them, we'll send you the right parts. So I don't even know what I'm going to do with those, but who knows. Anyways, that is the end that it belongs on the controller side. I might have a couple left in stock, but what I'm going to do right now is crimp the lug on this side. So I've got my good hydraulic crimper here, drilled a couple holes in a blank lug. I got a couple of these in my DigiKey order that I got here. I know I got another mess going again today. Then I cut one of the bus bars and shaved back the it's Scotch, what is it, 3M Scotch something, that is basically powder coated on there to make that bus bar touch safe, we'll call it. So I'll do something when I'm done. So I'll get this crimped on that wire there, and then we'll figure out how long I need it to come up here to get to the, I believe this is the negative side, so it'll come to the negative post, and give myself a wee bit of slack there, and then basically get onto the positive side. With these crimpers, you can't really crimp with one hand. I can get this started, but what I was going to say is it essentially turns that whole lug and copper wire into one solid glob of copper. Let's crimp this here, and then what I found with this one is it one thing you'll find is you will sometimes get a little sharp edge where it folds. This one's not too bad, just a wee bit of a edge there where my thumb is. My camera focus, there we go. But not bad, that one's actually pretty good. There's a little more on this side, I think, but it's pretty good. So now that's essentially one solid lug, and one of my friends had cut one of these apart and carefully polished it down to show the cutaway view of it, to prove it for aerospace stuff. And there, when you do it right, it is basically one solid. There's no room for, there's no air left inside there whatsoever. So some people think you should put some solder in there. I thought that at first too, but when these are crimped properly, that becomes one solid piece of copper, and that's the best connection you're going to get mechanically and electrically. The thing is, if you're relying on some solder and this connection gets hot because these bolts come loose or something, that's going to heat up and melt the solder, and it's going to come apart anyway. So you want a strong mechanical connection, and for that reason when doing high current stuff like this, you want a continuous lug. You don't want one of those ones that has the seam in it. The seam can come open because it won't hold the pressure. Like the car audio stuff is horrible. Most car audio lugs are just, well, at least the cheap ones you get at like Best Buy or whatever, you're gonna see they, when you crimp them down, they come loose easy if you crimp them really good with these crimpers. So anyways, this now comes up here like this. I gotta put my bolts in there, and then I can route my wire, continue on. Got the first wire done. Wanna see, buddy? So now what we gotta do is we gotta grab some heat shrink, We're gonna put some of this on there.
New one.
Yeah, it's a new one. Yeah, it's gonna be pretty close to that wire. Yeah, it's pretty close, eh? Okay. Let's put some heat shrink on there. You ready, buddy? We'll heat shrink this piece. We're gonna go like right there. Just keep going like that. This would be easier with some Prussian blue. Need to switch hands here. Bolt there. Got a rough idea where the hole needs to be. You can just barely see it there. Out there. Good. Should be good. What I might need to do with those, well, I've already kind of planned it. Some strain relief so that this can't twist this bolt loose here. I'll be using some red Loctite on these two bolts and then an epoxy over top of all of this stuff to try and electrically isolate it. But, okay, that's how that side will fit. I gotta route this wire up, bring it along this one, and then bring it up here. I'll probably put it to this one and skip this fuse. These fuses, these are actually 48 volt rated fuses. When they explode, there's a little glass shield there that explodes, and luckily when I blew one up, I didn't get pieces of glass shard in my eyes because I was wearing safety glasses, but it exploded glass shards all over in my face basically. I didn't get cut by it, but I was pretty damn lucky because they're pretty violent when they blow up. Especially, I think the one I was testing was on 300 and something volts, so I learned my lesson not to use that fuse for that high a voltage. It's only rated for 48 volts, so they shouldn't even really be on these controllers. Under this tape here, this is just temporary, this duct tape. Under here is a 170 volt rated custom fuse that Zero gets for these things. So basically, that's in the circuit. I think I can remove that. Route this positive wire right to the controller positive, and then start wiring the 35 pin amp seal. I need to put about roughly 10 wires in today. I need to put encoder, throttle, on off switch, and contactor. That's what you need to make it run, so I should be able to get that done today. That's my goal anyway. Let's see how it goes. And that one is done. So basically I gotta make a little bracket to mount the back of the contactor. I gotta figure out where I'm gonna route all my analog wires on off. I guess that's a IO, but basically analog and signal wires from the front through here back to the controller. I might drill a hole through the seat mount, or I might try and sneak them in here. I just got to look where the seat lets me put it. But that wire turned out pretty good. Got some heat shrink on there. Have to clean off some brake clean. And let's see, the wire supposed to come up like this. I have to get myself a little GoPro mount or something. So essentially what I'm getting at is and something to point out. I don't know which way is up or down with the camera. Hopefully it flips over. Something to point out is these bolts that go into the controller. You don't want to over torque them. I think the spec is like 8 foot-pounds or something, even though they're an 8mm bolt, which would normally be around 20-ish foot-pounds. The bottom of the stud that these thread into has 3 tiny little, I think they're M3 or M4 screws that go through a circuit board, and when you crank on them too much, it twists and deforms the circuit board, and it causes a short of some kind inside there. So anyways, what I'll do is I'll be bending this a little bit, giving it a little natural bend right there at the start, and then this will probably get a little, or my plan was anyway, to have a zap strap that holds the two of these together roughly here, or a little connector. I have a couple fancy connectors for that. I might just put one in the middle there, but these are going to get zap strapped to this tube here too. But for the most part, that's good for now. My wife just brought me another coffee. That'll be number 4, I think, for today. So by the sounds of things, that should mean I will be getting this running today. Also about to get some music happening. All right, I think I'm ready to try turning the main power on. I just got a switch here for now. I gotta figure out where I'm gonna put my main power switch, and this isn't gonna be what I use, but I've disconnected the contactor, and I do that for a reason, 2 reasons. In the software, I need to set the contactor voltage, because Sevcon actually will try and PWM the main battery pack voltage to control how much voltage goes in this. And for my math, I think this is a 12-volt contactor. So it should be safe to plug this into there. Now, of course, this is going to all get some mounting brackets and stuff when I'm done. So that plugs that in. So I should be able to turn this on and should see some information on there. This is a little bit sketchy, this part. There we go, there's our information. So it's going to give me a fault that the contactor, oh, it's got a couple faults, but that's fine. We're going to go in here and set this into pre-operational. And then get fault information. Throttle sequence, motor and thermal cutback, that's probably fine. I'll have to double check that my wiring to my motor encoder is correct. So then we're going to go in here. Okay, that's fine, I can close that. I can go in here, and what I want to do is look at my input outputs. I want to remember which, okay, pin 18 is my forward switch. So what I got to do is wire these wires here, which come from this switch up here, and I use that as a forward switch. So you have to start with the switch back, then you push it that way and it gives you forward. So I'm going to wire that, and then I'm gonna, before I do that, I'll also set my contactor voltage before I forget, and then I can come back and contactor setup voltages. Yeah, so that's good, I caught that. So let's put this to 15. Actually, even 15 probably safe, and then we're gonna put this at 10, I think, for starters. What that does is it gives it roughly 15 volts to pull the contactor in, and once it's been pulled in for 1 second, then it gives it 10 volts to hold it on. So what that does is it actually works as a built-in economizer in the Sevcon. That way the coil won't get too hot in the actual contactor. So we'll just double check that that's saved by clicking read values. Seems to, so should be okay. So I think I'm going to go back to yes, I need to make sure I set the forward switch. So I'm going to shut the key off, power off. And then I'm going to set the forward switch. Well, I'm going to wire this in for forward switch. Okay, I just connected up a couple grounds. This is all temporary. This connector I have here is off another bike, but I'm accidentally busted the tab there, so I gotta make a new one anyway. But I just want to get the wiring sorted out, because this has most of the wiring I needed. And then I'm probably gonna pop this chain off today, and I gotta set the encoder timing. So first step is to see if this likes what's going on. Let's close this. So it's in pre-operational. Let's see what kind of faults we get. It's just in pre-op. Let's double check that the encoder is the contactor is set correctly. Yeah, it should be okay. Let's see, tree, input, output. We have that, so let's go back to tree, and then let's get analog, raw analog inputs. And then we'll track the throttle voltage. That's full throttle. That off the throttle, 0, so we got a good throttle signal. So now the next step is just to shut it off, put it in operational, cycle the power, and then just see if the see if the wheel spins the right way. Is that the right way? Gonna look at this connector. It goes the other way. Trying to do these little connectors with one finger, one hand, whatever. Not easy. So now this is gonna say that. I'm gonna say okay. What I want to do. Sometimes it likes to give me issues like that, but it's usually pretty quick. So let's just turn this on. And I'm gonna have to hold my finger on this switch here. We got a contactor. So now we have to bring this window up. And what we're looking for, motor, that must be it there. I'm just gonna play it safe and set this here. Maybe I'll set this on Isaac's bike here or something. I don't even know. Everything's such a disaster in here. I don't even know where to put my phone. Just gonna set it there. I'm gonna try the throttle, but with my hand on the switch to see. We have no throttle. Oh yeah, forward switch. Okay, there we are. Oh, I gotta, you know what? I forgot something. Before I do that, I need to commission the encoder. Go back in here. PMC encoder. So now we have to spin the wheel by hand. And it takes off when I shut the switch off. We just want to turn the motor over a couple revolutions. And what that's going to do is it's going to get information from the encoder. Now I click this, and it should show us the information we want. So those numbers look probably acceptable. Close that. So now, okay, buddy, I need you to put your safety glasses and your earmuffs on and stay away. Maybe go stand on the stairs. So I have to apologize for the weak video. I'm gonna basically set my phone there, and I need one hand on my kill switch because I have a feeling my encoder timing is quite a bit off. So I want to put it out here, turn this on. Just looking to see if it spins the right direction. It shows me positive motor position. Okay, I'm going to get a sample. It's actually spinning backwards, but that's fine. Now, like I said, I actually got to do that test with the chain off. It sounds like it's spinning hard just because there's a couple things. The bearings are a little tight in the jackshaft housing, but it's actually also the timing's probably off by quite a bit, and I think the current level might be set down quite a bit. So let's go here, shut this. I'm gonna go in here. Now we gotta go PMAC encoder, graph voltage vectors. Where did it save it? Shows my timing way out of whack like that. So I'm gonna basically pop the chain off the motor and do that test again. Okay, to continue with this, basically I'm just going to pop this chain off here and let the motor spin with no load on it. And then I'll set the timing so we'll test the timing again. What you want is all these dots, the cluster to be straight up and down, but that's with no load on it. A couple ways to do it is just spin the motor at a steady RPM with no load on it, no chain. Another way a lot of people do it is spin it up on an inertia dyno and then just release the throttle and gather your sample with no load on the motor. And then what it's doing is sampling the phase alignment with the motor position sensor. So basically I'm just gonna pop the chain off and I'll test that again and see where they line up, and then make some adjustments. Nothing like dropping the camera. Just gotta pop those clips off. I think I designed this jackshaft housing for C3 clearance bearings, so they're a wee bit tight. I'm not super worried about it though. Now the motor will spin easy, so we can go back up here, turn this on. I'll get some safety glasses on. Anytime this stuff's live, you should have safety glasses on, and I'll probably put a piece of duct tape over that once I get testing more. I gotta make sure these get held down too, so I'll probably have to make a bracket for those rad socks. So let's close this. Let's enable that, rewind it, then we'll just start right away. Oh yeah, cycle the switch. I can tell by the throttle feel, the timing's out by quite a bit. Let's go back here. Yeah, I don't think that's right. So I can't remember if that's plus or minus. Let's just try. I'll know right away. So we can close this one. Go back here. Rewind. Play. I'll know right away because it'll be either easier. That sounds better, so I think I went the right direction. So then we stop. There we go here. Oh, I gotta go a bunch. Let's go 70. Always gotta click this rewind button. and play. Throttle's very touchy. Now we'll graph voltage vectors. This is not usually a very time consuming. Yeah, probably another 12 degrees, that's my guess. With no load on it, it's really hard to hold at 2000 RPM now. Typically, one thing you do is turn the throttle resolution down. You could scale your maximum torque to 10% instead of 100% like it is right now. But it's not that big of a deal. I've kind of got a feel for this now. Look at that. My guess of 12% was perfect. Now we'll put the chain back on. Alright, the chain is back on. Those are not quite touching the chain, so I just want to make sure we're okay. We're just going to spin it up a bit. There is one last, somewhat of a major thing to solve. It shouldn't be too challenging, but oh yes, gotta always cycle this. I have to flip that around. I like to have this switch so that when you push it forward, that means forward. When you push it back, it means reverse, which I have to install the other switch, and I'll do that in a minute. Sounds pretty exciting. All right, so the way this is set up should work now. Basically, turn that on. This won't do anything unless you start with this switch in the back setting and then go forward. So now it should run. Spins the right direction. I've got some throttle off regen set as well. But if it's running and you push this button, it kills it, and now the throttle doesn't work because that's actually a reverse button. So what you do, that actually works also as an emergency stop button, which is great. So, you know, if something happens, you can get your thumb on that switch, hopefully in a bad situation. So you switch this to reverse, still nothing. Then it's going to be hard to do this. Hold the, I don't even know how to do it. You hold that button down and it has reverse. So let's see. I'll just try it this way first. Now it's full throttle. It's only 300 RPM roughly. Okay, I flipped my phone over so that the camera's on the top, and I should be able to get a view of everything roughly. So basically I'll push the button now. And that's full throttle reverse. So it gives you torque control in reverse, but it's only limited to the 300 RPM that I programmed. So now that I let go of that button, like that's the trick. You have to switch this to back, which think of it as reverse. That's why I like to put the switch this way, this one here. And then you have to hold this button here down while you apply throttle to get reverse. So right now it won't do anything. So then putting it back and forward has all the power and forward. So that's good. I have to build a new variable regen lever, which will go up here where a clutch lever normally would go. Other than that, I have to rebuild that connector and clean up some wires. I build my new phase wires, but I think I can quickly pop the seat on, maybe a bit of duct tape over this live connection, and duct tape holding stuff down here just quickly, and the side shrouds and some zip ties, and maybe get a test ride in before dark. for a little test drive. Soon. It's dark out. Unfortunately, I didn't make it before dark today. But this app strap here should make this safe-ish to ride. For a quick test ride. Putting a little bit of a charge in the battery right now. That's probably okay. Put that in here. Figure out what to do with the on-off switch. No jumps or anything. That can be okay there, probably. Yeah, won't be the end of the world. Okay. Good old blue here. Can't use zip ties without one of these.